Hello there, and welcome back to the Sleepy Science. You're lying flat on your back, probably on a patch of grass that's just slightly damp, because the universe likes to keep things inconvenient. Overhead, the sky stretches wide and indigo, littered with stars like someone shook a salt shaker over black velvet. A soft breeze brushes past your ears, and the stillness settles in like a heavy blanket. You stare up and you try. You try to take it all in. The sheer verticality of the sky, the overwhelming scale of it, and almost immediately, your brain taps out. You're one little speck, clinging to the thin crust of a spinning rock, trying to understand a thing so vast that your entire world could vanish into one pixel of cosmic background radiation. You probably won't survive this. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Drop a comment with your location and local time. I want to know which corner of the world you're stargazing from tonight. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You're still staring up, and already it's a bit much. The moon looks deceptively close, like you could pluck it from the sky if you just had a good enough ladder. A plane drifts by, tiny and red blinking, and for a moment you feel like a god. But then your eyes adjust further and stars pop into view like shy fireflies. And suddenly you remember, your home is just the surface layer of a minor rock orbiting an unremarkable star in an unfashionable arm of a middling galaxy. There's no top, no bottom, no sky ceiling you can bounce a rock off, just up, and then more. It makes your teeth itch a little. Let's start small. Planet Earth. You know, the one with Wi-Fi and snack drawers and that one hill you always say you'll hike but never do. Earth has a radius of about 6,371 kilometers, which zero feels big until you consider the sun's radius is over 100 times that. A little detail the ancient Greeks somehow guessed pretty accurately, even without GPS or telescopes. Eratosthenes, back in 240 BCE, used nothing but shadows and a bit of math to estimate Earth's circumference, and he was shockingly close. Historians still argue whether he understood just how monumental his discovery was, or if it was more of a neat moment for him. Either way, Earth felt huge to him. It probably still feels huge to you when you're stuck in traffic or waiting for a delayed flight across continents. But compared to what's coming, Earth is a breadcrumb in a cosmic loaf. So now imagine zooming out. You rise slowly like a drone, then faster, ballooning up past the stratosphere, the thermosphere, the exosphere, until Earth starts to look like a child's marble, blue and white and spinning gently in the ink. The International Space Station hums beneath you, doing 28,000 kilometers per hour around the planet, like a fruit fly around an apple. You're still so close. The moon orbits at about 384,000 kilometers away, which sounds like a big number until you realize that's only about 1 light second. 1 second. If you had a flashlight powerful enough, your beam would hit the moon in the time it takes to sneeze and say, "Excuse me." And yes, space is mostly empty, but it's still heavy with history. Some ancient myths imagine the sky as a dome, or a layered sphere, or a celestial ocean with gods swimming through it. In the Norse cosmos, Earth was surrounded by 9 realms and a massive cosmic tree. Charming, but let's just say Odin didn't know about gravitational lensing. Historians still argue whether early skywatching cultures genuinely believed in these mythic models, or simply used them as metaphors for the unknowable. Either way, you're not that different. You're lying here, making up stories in your head to survive the abyss. Because here's the thing, even now in the modern age of space telescopes and interplanetary rovers, you don't feel the numbers. You hear them, millions of kilometers, light years, galaxies, but your poor brain still thinks in the scale of cereal boxes and parking spaces. To help yourself cope, you do what humans always do, you anthropomorphize. You pretend the moon is a face or the stars are watching you back. You squint at constellations and whisper made-up names for them. That one's the upside-down cat or sleepy burrito man. This is totally fine, by the way. It's the only way you get through this. And yet, you know there's more. You've seen those jaw-dropping space documentaries with Morgan Freeman narrating like he's personally piloting the camera. You've seen that image of Earth from Saturn, a pale blue dot in a black sea, taken by the Cassini probe while it was busy doing donuts around the ring giant. That image alone could break your heart. Or maybe you remember Carl Sagan's soft voice calling Earth a mote of dust suspended in a sunbeam. And you feel that, not in your head but in your chest, that tightness, that ache of perspective. Perspective is what gets you, not the numbers, not the data, but the feeling of zooming out. And you're not alone in this. Humans have been lying on their backs and freaking out under the stars since forever. The ancient Egyptians aligned the Great Pyramid with true north using the stars. The Mayans built entire calendars based on Venus. And in Australia, Aboriginal astronomy mapped dark spaces in the Milky Way, not just the stars. One shape, the emu in the sky, still stretches across the heavens, if you know how to look. Some fringe theories even suggest our entire mythological history is a coded star map. Sounds fun, until you realize your ancestors were basically playing connect the dots across the sky to stay sane. And here you are, doing the same thing. One star winks overhead. You wonder how far away it really is, how long its light has been traveling, if that star is even still alive. Maybe it exploded 1 million years ago and its light is only now finishing its marathon to your retinas. It's like being haunted by the past, one photon at a time. Now you start to imagine your own journey outward, leaving Earth, leaving the moon, hurtling toward the edge of something you'll never find. But that's okay, because tonight you don't need to understand it all. You just need to feel it. And that feeling, that vertigo, that dizzy edge of the diving board awareness, that's the first step. That's how you begin to comprehend the incomprehensible. You're going to love this. You squint at the stars overhead thinking, okay, how many are there really? You figure you'll try to count a few, just for fun. Maybe start with that bright cluster off to the left and work your way clockwise like some kind of galactic spreadsheet. 1, 2, 3, 20. Wait, did you already count that one? Or was that a satellite? You blink and 5 more have appeared out of nowhere. Your eyes aren't broken, just overwhelmed. Here's the truth, counting the stars is hopeless, completely, hilariously hopeless. Even with a perfectly clear sky and the world's finest eyeballs, you could maybe, spot around 2,000 to 2,500 stars from any one point on Earth. That's on a moonless night, far from light pollution, with the kind of commitment usually reserved for marathon chess games or assembling IKEA furniture without crying. Add both hemispheres together, and you're looking at about 5,000 visible stars total to the naked eye. But don't get too smug, those are just the local lights. Astronomers estimate that the Milky Way alone contains somewhere between 100 to 400 billion stars. That's billion with a B, and yes, that range is suspiciously wide. Historians still argue whether early telescope users like William Herschel were even seeing individual stars or just light smears from galactic clusters. At some point, the sky just becomes soup. And the Milky Way, it's not even a particularly large galaxy. Not tiny, sure, but kind of average. A dependable mid-size SUV of a galaxy. There are galaxies out there so big they make ours look like a junior varsity science fair project. So back to you. You gave up counting. Good choice. Your brain is simply not wired to process these kinds of quantities. Somewhere around 1,000, your mental calculator turns to oatmeal. This is known as the numerical distance illusion, the point at which numbers become meaningless to your gut. It's like someone telling you there are 8 million grains of sand on a beach. Cool fact. But your brain just shrugs and says, sure, sounds beachy, without truly absorbing it. Now imagine the stars. Every one of those tiny glints overhead is another sun. Some hotter, some cooler, some enormous bloated giants, others twitchy little dwarfs. Some have planets, some don't. Some of those planets are rocky, some have atmospheres, and some maybe, just maybe, have little creatures lying on their version of grass, also wondering what the heck all this is about. At this point in history, we've cataloged thousands of exoplanets, planets orbiting other stars, and some are even in the habitable zone, meaning they're not boiling lava pits or frozen wastelands. They're the planetary Goldilocks porridge, just right, if porridge came with tectonic plates and potential water cycles. But let's get a little weirder. There's a fringe theory that suggests our universe could be littered with rogue stars, burning alone, unmoored from any galaxy, adrift in intergalactic darkness, like fiery hermits or cosmic introverts. You won't see those in your backyard telescope, but they're out there. Probably, maybe. Historians still debate whether stars are evenly distributed across the universe or clumped together by some as yet undiscovered cosmic mechanism. Some even question whether we've misunderstood the gravitational pull of dark matter, which might make stars behave more like dust bunnies stuck to an invisible couch. Back to Earth, you're lying under this impossibly crowded sky, and suddenly it hits you. You are seeing the past. Every point of light up there is a time machine. That's not poetry, it's physics. Light takes time to travel, and most of what's reaching your eyes tonight has been en route for decades, centuries, millennia. Some of those twinkles, they started their journey before humans discovered fire. You're looking into the past, and the past is staring right back at you. This realization either makes you feel profoundly connected, or like your head's going to pop off and float into the stratosphere. Either way, welcome to astronomy. One fun wrinkle: even our own sun doesn't update you in real time. It takes about 8 minutes for sunlight to hit Earth. If the sun magically vanished right now, don't panic. It's statistically very loyal. We wouldn't know until 8 minutes later, like the world's most terrifying delayed notification. And speaking of things we can't quite wrap our heads around, take a moment to imagine how fast stars are moving. That star you're admiring casually, it's not just hanging out. It's hurtling through space at hundreds of thousands of kilometers per hour. Everything is in motion, constantly. Even you, even the grass you're lying on. Earth is spinning, orbiting, spiraling, and being dragged along in a galactic dance you'll never feel. It's kind of rude, really. You just wanted a peaceful night, and now you find out the entire cosmos is speedrunning away from itself. Which brings us to a humble little reminder. You're not seeing the universe as it is. You're seeing it as it was. If the sky is a painting, then it's one done in layers. The stars closer to us are the newest brushstrokes, the faint ones. They're ancient, cracking with time. Some are so old their original suns might already be dead, supernovaed, gone, and yet they still light your sky. It's a little like sending a message in a bottle across a cosmic ocean. And by the time the bottle arrives, your island has already sunk. Now you might be thinking, okay, but doesn't this mean we'll never see what the universe actually looks like now? Ding, ding, ding. You've just earned your honorary degree in existential disorientation. No matter how powerful our telescopes become, we're forever stuck in this lagging viewfinder. The deeper we look into space, the further back in time we're peaking. And since the speed of light isn't negotiable, we're always behind, always looking through a glass darkly. And here's the kicker: the stars you don't see far outnumber the ones you do. Our galaxy is dense with dust and gas that blocks light, not to mention light pollution down here. Your friendly neighborhood street lamps and shopping centers make it harder for your eyes to do their job. Ancient people had darker skies, clearer views, and probably way more panic attacks under the stars. Lucky them. Some astronomers believe that 90% of the stars in the Milky Way are hidden, either too faint, too shrouded, or too far to see with our current tech. And that's just in our own galaxy. There are roughly 2 trillion galaxies in the observable universe. If your brain just made a sad wheezing sound, you're not alone. So no, you can't count the stars, But maybe that's the point. Maybe comprehension isn't about tallying objects, it's about sitting in awe. It's about the hush that falls when you realize the lights above you aren't just decorations. They're evidence, history, long-dead messengers that say, hey, you're not the first to wonder. And you definitely won't be the last. You glance back up at the sky, blinking slowly, your brain still reeling from all those stars you'll never count. It's fine. Stars are out of your league anyway. But now a new thought creeps in, something more slippery, more abstract. You remember that thing from school about how fast light travels and how the universe measures distance not in kilometers or miles but in light years. A light year sounds poetic, also sounds like something invented just to confuse you. And yet it's one of the few tools humans have to even begin measuring the cosmos. Because space isn't just big, it's big in a way your monkey brain actively rejects. The numbers mean nothing. They might as well be flavors. So let's try to cheat. Let's start with something you think you understand: speed. Light travels at about 299,792 kilometers per second. That's fast. Too fast to visualize. You could circle the Earth 7 times in 1 second at that speed. You could microwave a burrito and be halfway to the moon before it dings. You could read this sentence and be on your way to Jupiter. But here's the catch: nothing can go faster than light. It's not just quick, it's the cosmic speed limit. The universe has rules, and light is the cop that enforces them. Even the speed demons of physics, like neutrinos or gravitational waves, don't dare cross that line. It's a fundamental constant, the fabric of realities, do not pass sign. Historians still argue whether this limit is baked into the universe's geometry or simply a mathematical artifact of our current models. Either way, you're stuck with it. Now try wrapping your mind around this. If something is 1 light year away, that means the light from it takes an entire year to reach your eyeballs. So when you look at Alpha Centauri, the closest star system to us, you're seeing it as it was about 4.3 years ago. It's like getting a delayed text message from the past. And yes, you could hypothetically get in a spaceship and fly there, but at current human spaceflight speeds, it would take you over 75,000 years. Hope you packed snacks. Here, where things start to get wild, our solar system is about 0.001 light years across. The Milky Way, roughly 100,000 light years wide, and the observable universe, meaning the part we can actually see, is about 93 billion light years in diameter. Wait, hold up. Billion. How can we see 93 billion light years away if the universe is only about 13.8 billion years old? Great question. You're already asking the terrifying ones. Here's the twist. Because space itself is expanding, the light that started traveling toward us billions of years ago has been chasing a moving target. It's like running up an escalator that's stretching out in front of you. The galaxies are far, yes, but they're also getting farther as we speak. This means that while the light we see may have traveled 13 billion years, the actual objects that sent that light are now much, much farther away, hence the 93 billion figure. It's like cosmic inflation, but with 0% APR and total existential dread. In fact, the expansion of space is such a big deal that it warps your sense of distance entirely. 2 points in space don't stay fixed, they stretch apart. Not because they're moving through space, but because space itself is growing. Imagine baking a raisin cake. As the dough rises, the raisins all get farther from each other, even though they're not moving on their own. Congratulations, you're now a baked good metaphor. Einstein's general theory of relativity predicted this, though even he wasn't thrilled about it. He originally added a cosmological constant to his equations to make the universe stay static. When it turned out space was actually expanding, he reportedly called the constant his biggest blunder. Historians still debate whether he meant that literally or just hadn't had enough coffee that day. Now your mental gears are turning. If space can stretch and the speed of light is a limit, then surely there are parts of the universe we'll never see. Ding, ding, ding. Welcome to the cosmic horizon. There's a boundary beyond which light will never reach us. Not now, not ever. Not even if we wait forever with really good telescopes and unlimited popcorn. The expansion of space outpaces the speed at which light can travel to us. This means parts of the universe are permanently beyond our observational reach. Some scientists call this the particle horizon, which sounds cool, like something out of Star Trek, but really it's just the edge of what we can know. Beyond that, it's not darkness, it's unknowable. Imagine that, an invisible boundary beyond which galaxies might be doing the tango or exploding into glitter, or maybe not even existing at all. You'll never know. The universe has secrets and it's keeping them. And here, where things get even spicier, time and space are tangled together. Because of relativity, your sense of distance and time is elastic. If you could travel close to the speed of light, time would slow down for you compared to someone back on Earth. In theory, you could take a trip that feels like a few years, only to return home and find that centuries have passed. It's called time dilation, and yes, it's very real. GPS satellites have to account for it, or your phone would think you're in the wrong zip code. So now, imagine trying to measure the size of the universe under these conditions. You're playing with a ruler that stretches and bends depending on how fast you're moving, where you are, and how space itself is behaving. It's like trying to weigh a cloud with a spoon. Some fringe physicists have even proposed that the speed of light itself may not have always been constant, that in the early universe, light might have moved faster. This theory, still hotly debated, could solve some of the thornier problems in cosmology, like why distant parts of the universe look so eerily similar. But it also makes your job of understanding any of this even harder. Still with me? Let's take a breath. Because here's the secret, you're not supposed to fully grasp it. Not really. These numbers, these speeds, these impossible distances, they're scaffolding. What matters is the feeling. That moment when you realize you're part of something incomprehensibly vast, and yet somehow, incredibly, you can still wonder about it. That's your superpower. The universe may be uncountable, untraversable, and totally indifferent, but you're the one lying under it asking questions. You're the one whispering up into the dark, how far does this go? And even though the answer might be farther than you can imagine, you keep imagining anyway. And that's light-speed thinking. You close your eyes for a second, just a second, and when you open them again, you're floating. No spaceship, no gravity, no fuss. Just you, gently drifting upward through the inky black, watching Earth shrink beneath your feet like a loading screen zoom-out animation. Don't worry, you've got infinite oxygen, perfect temperature control, and zero risk of space pigeons. It's just you and the void now. Below the planet is a swirling marble of blues and greens, already looking suspiciously small. You give a lazy wave goodbye to the continents, so long, awkward land borders, and begin your great departure. Time to zoom past the planets. First up, the moon. Easy. You clear it in seconds. Just another rock, really, though it holds a weird place in your heart. A chunk of Earth's past, torn off in a violent impact, still orbiting faithfully like a ghost that doesn't know it's supposed to move on. Then comes Mars, reddish and moody, everyone's favorite science crush. You slow just enough to admire Olympus Mons, the largest volcano in the solar system. It's about 3 times taller than Mount Everest, which feels unnecessary, frankly. Show-offy. Historians still argue whether ancient Martian riverbeds mean the planet was once wet and lush, or just suffered from severe seasonal flooding. Either way, you're not stopping. It's getting chilly out here, and the real wilderness is ahead. Past the asteroid belt, you reach Jupiter, a monstrous ball of gas with a gravitational pull that could make your bones sing. Its great red spot stares at you like a slow-motion storm eye, bigger than Earth and somehow still going after hundreds of years. Imagine a hurricane that outlasts every dynasty in human history. That's commitment. A few of Jupiter's 90-plus moons wave politely. Ganymede, the largest moon in the solar system, flexes its icy crust like a frosty bicep. Europa gives you a nudge of mystery. It may have a vast, dark ocean beneath its shell, possibly with alien microbes doing the cosmic cha-cha. NASA's future missions plan to investigate. You'd go now, but there's a schedule. Saturn spins into view next, and let's be honest, you linger here. The rings are too pretty to ignore. Like shattered moon glass or the universe's own vinyl record collection, the rings glitter as they catch the sun. They're only about 30 feet thick in places, which is weird considering they can stretch over 280,000 kilometers in diameter. One fun fact for your sleepy brain: if Saturn's density were any lower, it could theoretically float in a bathtub big enough to hold it. Fringe idea, maybe, but also a hilarious mental image. After Saturn, things thin out. Uranus rolls into frame sideways because of course it does. This planet is tilted over 90 degrees, so its poles face the sun like a lazy teenager refusing to sit up straight. Scientists still aren't sure what knocked it over. A rogue planet, a cosmic fender bender. Historians still debate whether Uranus's tilt is a one-time accident or part of some ancient orbital dance we've forgotten how to track. You zoom past it with only a half smile. Yes, you made the joke in your head. No, we won't dignify it here. Neptune is next. Icy, windy, and deep blue like the ocean you still miss just a little. Its winds can reach 2,100 kilometers per hour, faster than anything recorded on Earth. Basically, if Neptune had a weather app, you delete it immediately for anxiety reasons. And then that's it. You've passed the planets. You've exited the well-mapped region. From here on out, the signs get fuzzy. The borders blur. Welcome to the fringes of the solar system, where things get slow and weird. But before you float too far into the next great nothing, let's put this in perspective. It took the New Horizons spacecraft about 9.5 years to reach Pluto. That's with gravity assists and the best engineering humans could muster. It zipped past in 2015, snapped some incredible selfies, and then just kept going, waving goodbye to the last textbook planet, RIP Pluto's status, and entering interstellar space. You, though, you're doing this all in one dreamy glide. And yet, even at this impossible speed, you're realizing something painful. You're still so close to home. Even after blowing past every planet, you haven't even cleared the cosmic driveway. If the solar system were the size of a football field, you've barely stepped off the welcome mat. Let that sink in. You're over 5 billion kilometers from Earth, and yet in galactic terms, you've moved basically nowhere. The nearest star, Alpha Centauri, is over 40 trillion kilometers away. Trillion. With a T, you'd have to multiply your entire solar system's size many, many times before you could even pretend to call that distance manageable. To make things more humbling, light takes over 4 years to travel to Alpha Centauri, and the Voyager 1 spacecraft, still bravely beeping data back to Earth after all these years, won't get within a light year of another star for over 40,000 years. At this point, you're floating past all known planets and looking back. The sun, once a fiery presence, is now just a bright dot. Earth, not even visible anymore, just the faint memory of blue. And you, a dreamer in motion, surrounded by silence so total it feels like time has paused. Space isn't just empty, it's lonely. It's a kind of loneliness no poem can prepare you for, a silence deeper than silence, but it's also calm. There's no traffic, no buzzing phone, just you and the yawning dark. And as you keep floating, your thoughts begin to stretch out too. You think about all the ancient humans who stared up at the same stars, never knowing they were peering out through a pinhole of time and light. You think about the math, the engineering, the stories, the poetry, all of it built to give shape to something we'll never touch. You think about how fragile everything feels now, how brief, but also how utterly beautiful it is. and you haven't even left the solar system yet. You keep drifting. The planets are gone now. No more cozy gravitational hugs or bright rings to entertain your eye. Behind you, the solar system is a glowing speck, like the distant light of a street lamp on a foggy road. Ahead, more black, the kind of black that feels alive, like it's listening. And then somewhere in that vast silence, you sense it. A tiny, tireless signal still pinging away. It's Voyager 1, humanity's little emissary to the stars, still going, still trying. The spacecraft was launched way back in 1977, which, if you're keeping track, means it's been traveling for over 48 years. It was supposed to visit the outer planets, snap a few selfies, and then vanish into the night. But Voyager had other plans. It has now officially entered interstellar space. That means it has left the heliosphere, the bubble of solar wind and magnetic fields that surrounds our solar system like a protective aura. Sounds dramatic, and it is. But here's the wild part. Voyager 1 is still technically inside the solar system. Yes, really. Because out here, distances get fuzzy. The solar system doesn't just end after Neptune like the diagrams in school books would have you believe. There's a vast, sprawling, invisible cloud called the Oort cloud, and Voyager is still millions of years away from exiting it. Historians still argue about where the solar system ends. Is it the edge of the sun's gravitational pull, the edge of the heliosphere, the start of the Oort cloud? The truth is, space doesn't like labels. It's messier than that. So Voyager's drifting, still within the sun's kingdom, but way past the last throne. At about 24 billion kilometers from Earth, Voyager 1 is the farthest human-made object in existence. It's not much bigger than a school bus, and it's carrying a golden record. Yes, a literal gold-plated LP, filled with greetings, music, whale songs, and a cosmic mixtape for anyone or anything that finds it. Fringe theory time. Some speculate that if intelligent aliens ever intercept Voyager, they might be confused by our choice of sounds and images. Chuck Berry's Johnny Be Good is on the record. No offense to Chuck, but if that's humanity's first impression, we'd better hope the aliens like rock and roll. But Voyager's mission wasn't to find aliens. It was to send a message, a proof of life, a whisper into the void that says, "We were here." You float alongside it for a while, listening to the faint, regular pulse of its systems. It's slowing down. Its instruments are gradually going dark. Sometime in the next decade, Voyager's power source, a radioactive decay generator, will finally give out. And when it does, Voyager will go silent. But it won't stop moving. It'll drift for thousands, millions, billions of years, through a darkness so deep even light gets homesick. At this point, your perspective starts to twist. You've passed every object you've ever known, and you're still in what amounts to the solar system's front yard. The scale is brutal. You begin to wonder if this feeling, the weight of infinity pressing gently on your chest, is what early sailors felt when they stared across endless oceans with no land in sight. Except this isn't an ocean, oceans end. And out here, Voyager is your last breadcrumb. It's not the only one, though. Voyager 2 is also on its journey, though on a different path. And Pioneer 10 and 11, both launched in the 1970s, are out here too, silent now, but still moving. Little silent dots with fatting trajectories, each one carrying a plaque etched with human figures and a map back to Earth. Historians still argue whether these messages were wise. Some say we shouldn't broadcast our location to the universe. You wouldn't shout your home address into the void if you didn't know who or what might be listening. But again, that wasn't the point. These spacecraft aren't just about science. They're about hope. They're time capsules of our curiosity, the cosmic equivalent of throwing a note in a bottle and hurling it into a black, endless sea. You squint at Voyager again. It's tiny, it's old. It's incredibly, impossibly brave. And it reminds you, we've barely begun. Because the space between stars isn't just distance, it's emptiness. So much so that when Voyager crossed into interstellar space, there was no sudden scenery change. No fireworks, just a slightly different density of particles. More cosmic rays, fewer solar winds, that's it. A boundary crossed that no one can see. Let's put this distance into context. If the sun were the size of a beach ball, Earth would be a pea about 15 meters away. Voyager, it would be over 600 meters from the sun now, and still hasn't reached the next beach ball. You're finally starting to get it, aren't you? The scale of the universe isn't just large, it's deeply unfair. It laughs at your sense of proportion. The way you measure roads, countries, even planets. Useless out here. Your human instincts scream for closure, for edges, for destinations. But space doesn't do tidy conclusions. It's all halfway points, endless gradients, and vanishing horizons. And yet you're still going. Still floating forward through the dark. Somewhere behind you, Earth spins on, blissfully unaware of how vast the silence around it really is. People are arguing over coffee orders. Cats are knocking things off tables. And here you are, watching humanity's oldest space probe become the last firefly in an enormous, moonless forest. You don't feel fear, though. You feel something else. Something softer. Like awe, maybe. Or surrender. You're not supposed to win this game. You're just supposed to see it. To feel it press in from all directions and still whisper, more. Because this is still the beginning. You turn your head gently, slowly, because out here in the deep silence of space there's no rush, no clocks, no ticking, no pressure. And there it is just ahead, a great diffuse shell, faint, almost imaginary. The shape isn't sharp, the edges barely distinguishable from the darkness around them. But it's there, stretching out like a ghost around the solar system. Welcome to the Oort cloud, the distant, hypothetical shell of icy leftovers that forms the true outer boundary of our solar system. Or at least, the best guess at where our sun's family finally ends. This is the part of the cosmic map marked with "maybe here be comets." You float toward it, feeling the cold increase. Not because temperature means anything in the vacuum, but because the absence of warmth here is complete. This far out, the sun is just another star. Its familiar glow has been reduced to a piercing dot. No warmth, no light, just gravity barely hanging on. The Oort cloud is theorized to extend from 2,000 to 100,000 astronomical units, AU, from the sun. For scale, 1 AU is the distance from Earth to the sun, about 150 million kilometers. So yes, we're talking numbers that leave your jaw somewhere in Neptune's orbit. Historians still argue whether the Oort cloud even exists in the form we think it does. No one's actually seen it. We've inferred it, like detective work on a crime scene billions of kilometers away. We know comets like Halley and Hale-Bopp must come from somewhere. And they come screaming into the inner solar system on long, looping orbits that suggest they were launched from way out here. Fringe theory alert. Some astronomers believe a second sun, a hypothetical dark companion to ours nicknamed Nemesis, could have stirred the Oort cloud in the past, sending waves of comets toward the inner solar system and potentially triggering mass extinctions. Sounds dramatic and very cinematic, but there's no real proof. Still, it's a spicy idea. But even without cosmic villains, this place is busy in its own quiet way. The Oort cloud may contain trillions of icy bodies, frozen rocks, comet seeds, sleeper agents of the solar system, waiting for a gravitational nudge, perhaps from a passing star or a wayward planet, to kick them into motion. A sneeze in the fabric of space could send one plummeting toward the sun, painting a streak across Earth's sky 10,000 years later. You drift past a slow-moving lump of ice no bigger than a mountain. It's been here since the dawn of the solar system, untouched, unbothered, unknown. If it had a face, it would look bored. These objects don't rush. Their orbits can take millions of years to complete, swinging out into the dark and crawling back in like shy ghosts. And here's the real kicker. Voyager 1, that brave little spacecraft you just passed, won't even reach the Oort cloud for another 300 years. It will take 30,000 years to pass through it entirely. You're cheating by flying dream speed. Voyager doesn't get that luxury. It crawls. You look around, there's no orientation here, no up or down. The sun's influence is still here, but barely. The planets are memories, the stars in the background, all part of the greater galaxy now, not guiding lights but wallpaper. And still, you haven't escaped the solar system. The Oort cloud is the solar system. It's the dusty halo, the bubble of icy crumbs that gravity holds like a faint breath. Some scientists call this the cosmic freezer, where things are preserved from the early days, long before Earth had continents, long before anyone was nomming stars or baking pyramids under the desert sun. One historical fact that floats to mind as you spin gently through the dark. Back in the 1950s, a Dutch astronomer named Jan Oort proposed this entire structure based solely on the behavior of long-period comets. No spacecraft, no telescopes powerful enough to see it, just math and hunches and skywatching. A quiet reminder that sometimes, the best science starts with a really good guess. Historians still argue whether Oort was building on earlier work, or if he truly deserves sole credit for the theory. Science, like comets, often has a long, winding tail of contributors. Meanwhile, you've stopped trying to measure this place. It's too abstract. The Oort cloud isn't a destination. It's more like an atmosphere of potential, an icy edge to the story of the sun, where creation spills into chaos. And somewhere inside you, a quiet thought lands like a feather. How much more is out there? Because if this is still part of home, what happens when you finally leave? You spin slowly, letting your eyes trace the emptiness. A few of those icy bodies might have companions, tiny moonlets, trailing pieces from ancient collisions. Maybe once, two comet cores glanced against each other here, merged, and began a slow dance that will take 10,000 years to complete one orbit. Maybe somewhere out here is an object we haven't even dreamed of. A Planet 9 tugging invisibly on the orbits of distant objects, shaping the darkness with unseen hands. Fringe? Sure, but not impossible. The math has been whispering about something big, something heavy, a gravitational ghost. We just haven't found it yet. Still, even that would be just one more ice ball in a sea of ice balls. And the sea, it stretches and stretches. Eventually, you'll drift so far that even the Oort cloud fades. No more ancient snowballs, no more faint gravitational tethers, just space. Not the vacuum between planets, not even the space between stars. Interstellar space. And this time, you really mean it. You glance back one last time, even though it's almost laughable. There's nothing to see anymore. The sun's influence is a whisper. Earth, the moon, the entire solar system, they're somewhere behind you, compacted into a dot too small to point at. And you realize you've never been farther from home. But strangely, you don't feel fear. You feel weightless, not just physically, but emotionally. The kind of freedom that comes from understanding that your worries, your routines, your little human dramas, they never made it past the asteroid belt. Out here, you're just stardust, floating through its origin story. And in a moment, you'll tip forward into the Milky Way itself. But first, just breathe. Let the chill of the void settle in your chest like snow. Let the silence become music. Let the fact that you're still within your own solar system after all this be the most mind-bending twist of all. Because the real journey, it's still waiting for you. You tilt forward again. There's no ground, no thrust, no trajectory, just motion like falling without the fall. The Oort cloud is behind you now, and with it, the last crumbs of home. You've stepped over the doormat and into deep space. This is interstellar space, and if the solar system was your city, this is the desert that stretches beyond it in every direction. No roads, no signs, no helpful gas stations with clean bathrooms. Just the big empty. But don't let the silence fool you. It's not dead out here. Space is emptier than anything you can comprehend, far more vacuum than any vacuum your brain wants to believe. In the vast stretches between stars, there may be just a handful of atoms per cubic meter. On Earth, that number is about 1025 atoms per cubic meter. Out here, it's closer to 1. And yet somehow space still hums. The void isn't quiet in the way a library is quiet. It's quiet in the way an ancient forest is layered, alive with subtle motion, hiding sounds too deep for your ears. Out here, radiation zips silently between stars. Particles swirl in the dark, remnants of solar winds, galactic rays, and distant supernovae. Occasionally, a gamma ray bursts past like a bullet fired from a galaxy you'll never find on a map. Historians still argue whether the interstellar medium, this thin soup of particles and energy, is simply leftover debris from stellar formation or a dynamic part of galactic evolution. Some even suggest it plays a role in star birth, like an invisible womb out in the darkness. Not bad for something that looks like nothing. And there are things in this nothing. Drifting objects, lumps, stragglers. Rogue planets. You pass one now. It doesn't spin around a star. It's alone, completely severed from any solar system like a marble lost under the cosmic couch. It's dark, massive, and quiet. No warmth from a sun. No moon. Just a giant rock ball of frozen clouds and iron storms. It tumbles endlessly, bound to nothing. Fringe theory incoming. Some scientists think there may be more rogue planets in the galaxy than stars. Billions, perhaps trillions, of lonely worlds kicked out of their systems or formed in solitude, drifting like orphaned chess pieces across the board. And yes, some of them could have atmospheres, internal heat, maybe even liquid oceans beneath thick ice. The idea that life could exist on a rogue planet with no sun at all makes your neurons itch. But it's not impossible. There are life forms on Earth that thrive in pitch-black ocean vents, feeding on heat and minerals instead of sunlight. Who's to say a distant cousin isn't doing the same out here, beneath a shell of frozen nitrogen? You feel the cold, even though you're not supposed to feel anything here. It creeps into your thoughts, into your sense of time. You're not moving slowly exactly, but everything around you is. You pass a tiny hydrogen atom, floating alone, minding its business. It's one of the most common things in the universe, yet this particular atom has been adrift for millions of years, untouched by planets or stars or forces strong enough to pull it into anything. Just a lonely dot in the most ancient soup. And then there's the radiation. The background hiss of the universe. Leftover heat from the Big Bang, stretched thin by time into the faint cosmic microwave background. It's everywhere. You're bathing in it right now, like a ghost warming itself on the embers of creation. This radiation is barely above absolute zero, just 2.7 Kelvin. But it's a reminder that everything came from somewhere, that even the emptiest parts of space still remember their birth. There's movement too, subtle tides of plasma, drifting currents of charged particles that slowly carve the space between stars. Some are pushed by old solar winds, some stirred by magnetic fields you'll never see. It's like watching clouds made of nothing, dancing to a song played on frequencies your ears were never built to hear. And just when you think you've reached peak solitude, your dream speed coasts you past something stranger. A bow shock. No, not a weapon, not a sudden noise. A structure, almost a wave, formed when solar winds from our star collide with interstellar particles. You're at the outermost wake of the sun's journey through the galaxy, and it leaves behind this soft ripple in the interstellar medium. Imagine a boat moving through still water. The waves it leaves behind are this, delicate, invisible pressure fronts, like fingerprints on dark glass. You spin slowly, letting your arms drift as your perspective pans out. There's no floor, no center, but you are somewhere. You're in the galactic suburbs now, floating between stars like someone who missed their train and decided to walk to the next city at night in winter across a frozen sea. And it is beautiful. You can feel the vastness now in your spine. It's not just a number anymore. It's a feeling, that heavy, humbling stretch of distance between one star and the next. Even at light speed, it would take years to travel between them, and you're not even aiming for one yet. You're just floating in the nowhere between everywheres. You pause, let it hit you. This is what it means to be small, not as a flaw, not as a punishment, but as a perspective. You are one tiny note in a symphony playing across trillions of years and light years. You don't need to understand every instrument, just listen. And maybe this is the weirdest part. Even in the middle of all this vacuum and stillness, you don't feel alone. Because you know, somewhere back on Earth, someone is looking up at the stars right now just like you did. Maybe they're wrapped in a blanket. Maybe they're trying to impress a date. Maybe they're asking big questions. Or maybe they're just counting stars they'll never finish. But they're feeling it too, that little breath of cosmic awe. The interstellar void isn't empty. It's full of questions, possibilities, memories, and time itself. And you're just getting started. You finally look up, or what feels like up, because direction has stopped meaning anything. You're out past the comets, past the last tendrils of the solar system, past even Voyager's fatting signal. And now, like someone exiting a dark tunnel into a blinding open plain, your eyes adjust to something else. There it is, the Milky Way. You're not outside of it, not yet, but you can see it now in a new way, no longer just a glittery smear across the sky from some desert campsite. Now it's everywhere, massive, messy, luminous. And you live in it. You start drifting through one of its spiral arms, the Orion Arm, or more precisely, a smaller spur called the Orion Cygnus Arm, like a little side street off a galactic freeway. It's the Milky Way's equivalent of a quiet suburban cul-de-sac. Not too crowded, not too lonely, just enough stars to keep the lights on. Our sun isn't anywhere fancy. It's not near the center, not on the edge, just floating somewhere about 27,000 light years from the galactic core, orbiting it lazily every 225 to 250 million years. So yes, the last time the solar system was in this part of its orbit, dinosaurs hadn't even evolved yet. The continents were still clumped together in one confused blob called Pangaea, and Earth's air smelled a lot more like volcanic burps. Historians still argue whether the solar system's position in the galaxy played a role in life's development, whether quieter galactic neighborhoods are safer for complex organisms. Fewer supernovae, less radiation, fewer rogue black holes tossing planets around like marbles. Honestly, you're lucky you weren't born closer to the center. Because speaking of the center, as you move inward through the Milky Way, the view changes. The number of stars ramps up. The blackness thins. It's like flying toward a city from a rural highway at night. The soft, creeping glow becomes a dense, blinding grid. You're entering the galactic disk, and it's thick with stars, gas, and dust. This is where galaxies do their business. Stars are born here, live, and die in spectacular, over-the-top fashion. You pass clusters of blue-white giants, burning fast and dying young, and slow, cool red dwarfs that will outlive entire galaxies. One particular cluster catches your eye, the Pleiades, a tight group of hot young stars, still wrapped in a veil of cosmic dust like a newborn swaddled in starlight. It's a common sight from Earth, often mistaken for the Little Dipper. But from here, it's radiant, alive. You keep moving. Nebulae drift past like jellyfish, giant clouds of gas and plasma in every shade of violet, teal, and blood red. The Eagle Nebula, the Carina Nebula, the Lagoon Nebula, each one a nursery of stars in the making. They swirl and pulse, glowing under ultraviolet light from the newborn stars deep inside. You try to focus on one structure, but the Milky Way overwhelms you. Its spiral arms stretch out like vast, stellar hurricanes, each one containing billions of stars. Not millions, billions. Every star potentially with its own system of planets, moons, comets, maybe even people. Fringe theory moment. Some astronomers believe the Milky Way may have hundreds of rogue civilizations, hidden by distance, timing, or technology. Some might be broadcasting signals we just haven't heard yet, or maybe they've gone quiet on purpose. You can't help but wonder, if they're out there, are they floating too, drifting between stars, looking back toward their own version of home? Your gaze drifts again toward a denser patch in the galactic middle. That glowing heart, the galactic bulge, contains the Milky Way's most mysterious resident, Sagittarius A*, our galaxy's central supermassive black hole. It's not a monster, not a vacuum cleaner. It just is. Massive beyond comprehension, with the weight of over 4 million suns compressed into a space smaller than a solar system. And it's quiet, dormant even. Not all black holes scream. Some whisper. Historians still debate whether our black hole was always there or formed later, after ancient galaxies merged. Some believe it's the anchor holding the Milky Way's spiral arms in place, like a pin in the middle of a spinning map. You pass closer to the core than anyone ever has, and for the first time you sense not just light but structure. There's motion here, coordinated, almost architectural. Gas clouds orbit at breakneck speeds, stars sling around invisible corners, and every few thousand years, something massive disappears forever. And then you drift back out toward the arms. You notice strange patterns, stellar streams that twist and arc through the galactic disk. These are the remains of cannibalized galaxies, torn apart and absorbed by the Milky Way over billions of years. Galactic ghosts, bones of cosmic prey. The Milky Way didn't form peacefully. It's a mosaic of smaller galaxies stitched together over time. Some of those stitches are still visible. One dwarf galaxy, Sagittarius Dwarf, is currently being consumed, star by star, like an appetizer for a hungry spiral giant. Fringe speculation time. Some physicists think the spiral structure of galaxies might be illusory, created by waves of star formation moving through the disk like ripples. Others argue the arms are long-lived physical structures. The debate continues, and here you are, floating in the thick of it. You pass a dense cluster of red dwarfs, some so dim you almost miss them. These are the quiet stars, the ones that burn low and slow for trillions of years, the true long-haul survivors of the cosmos. If any life wants to hunker down and stick around, it'll probably do it here. You're starting to feel the shape of the Milky Way now, not just its span, but its behavior. A galaxy isn't a static object, it's alive. It churns, it devours, it gives birth. It spins once every couple 100 million years, dragging solar systems along like sequins on a turning disco ball. And you're in one of those sequins, somewhere in the quiet arm, barely a footnote. And yet, despite the noise, the motion, the sheer number of stars, you can't help but feel this place has a rhythm, a strange, silent tempo, like the Milky Way is humming to itself, a sound too low to hear, a vibration too slow to measure. You think of how ancient humans named the Milky Way after spilled milk, river trails, god pathways. You think of how every culture has looked up and told stories about this band of light. And now, you're swimming through it, weightless and blinking at the view. Here, the stars aren't twinkling points. They're glowing orbs hurling plasma in all directions. You see flares erupt. Magnetic fields twist like dragon tails. A binary star system blinks nearby, two suns locked in endless orbit. One red, one white, dancing. And in all this chaos, you still feel calm. Because this isn't danger, this isn't fear. It's perspective, pure and vast and utterly humbling. You're not alone. You're not central. You're not even visible. And still you belong. You blink slowly, though blink might be generous. Out here, your eyes aren't even sure what they're doing anymore. There's no wind, no gravity tugging at your lashes, no air to blur the light. Just clarity, raw, humbling clarity. The Milky Way still stretches behind you like a luminous whirlpool, a brilliant pinwheel of light, gas, dust, and chaos. You can still sense your place in it, your old neighborhood back in the Orion Arm. But now you float beyond its reach. You've crossed the threshold, slipped between stars, and kept going until even your own galaxy feels like just one bright swirl in an ocean of glitter. Because now you're surrounded by them. Galaxies everywhere. They dot the void like a cosmic snowstorm frozen in time. Not just dozens, not even hundreds, billions. Each one a Milky Way in its own right, or bigger. Some spiral, some elliptical, some just vague blobs of light. A whole universe of island cities glowing in the dark. You're not prepared, you can't be. You saw this before, back in your Earth days, maybe in that iconic Hubble Deep Field photo. Remember, that unremarkable patch of sky that, when magnified, turned out to be absolutely teeming with galaxies. Each smear of light a home for billions of stars, each star potentially orbited by a family of planets. From a telescope, it was astonishing. From out here, it's unreal. You drift past a spiral galaxy not unlike your own. Its arms are twisted just a little tighter, its center a little brighter. You wonder how many civilizations might be there right now, wondering about you maybe, or forgetting you even exist. To your left floats a galaxy that's colliding with another, NGC 2207 and IC 2163, tangled in a slow-motion cosmic embrace. The process takes hundreds of millions of years, so you're catching it mid-sentence. Stars are flung like sparks. Gas clouds stretch like taffy. It's destructive and creative all at once. Galaxies crash, but stars are born from the wreckage. Historians still argue whether our own Milky Way has done this before. Spoiler, it has, multiple times. It's absorbed smaller galaxies like appetizers, quietly, efficiently. A galactic survival mechanism. You catch sight of a ring galaxy, a rare beast, a near-perfect circle, glowing like an ancient halo. How? Probably a head-on collision. One galaxy punched through another like a bullet, triggering a wave of star formation that spread outward in a near-perfect ring. Fringe theory time. Some physicists speculate that galaxy shapes may contain information, hidden codes from earlier epochs of the universe, like fossils with embedded data. It sounds like science fiction, and maybe it is, but then again, everything out here feels fictional. You pass near a massive elliptical galaxy, M87, home of the first black hole ever imaged. You remember that donut-shaped shadow from 2019, don't you? It was huge. It was famous. It was blurry, but it was real. That image was the first time humanity had proof that we could stare directly into the abyss and get something back. And now here you are, floating past the very place. The black hole at its center weighs 6.5 billion solar masses. It's so heavy that time itself slows near its edge. It doesn't suck things in, it simply bends the rules, like a loophole carved into space-time. You keep moving, skimming the edge of a galaxy cluster. This is where things get serious. Galaxies don't drift alone. Most of them are part of larger gatherings, some loose, some tight. The one you're drifting through now, it contains thousands of galaxies, some the size of the Milky Way, some even larger, all bound together by gravity and dark matter, that mysterious scaffolding that makes up most of the mass in the universe and refuses to explain itself. Historians still argue whether dark matter is a substance, a field, or just a misunderstanding of gravity. It doesn't emit light, doesn't interact with regular matter, but it's there. Galaxies spin faster than they should, as if held together by invisible glue. You pass through a glowing haze, the intracluster medium, filled with hot X-ray gas that suffocates would-be galaxies and feeds the black holes at the centers of others. Galaxy clusters are not peaceful places. They are dynasties in constant motion, merging, competing, devouring. The cosmic equivalent of empire building. and yet still quiet. There's no noise in space, but there's vibration, energy. If your bones could hear, they'd be humming. You realize something. We call them island universes, but they're not islands. They're continents sprawling, connected through gravitational bridges, dark matter highways, and rivers of gas. Some clusters are part of superclusters, connected like filaments in a three-dimensional web. Our own galaxy is part of one called Laniakea, which roughly translates to immense heaven in Hawaiian. You'll be drifting through that neighborhood soon, but first, you can't help but take in the colors. Galaxies aren't all silver and white. Some are tinged blue, full of young, hot stars still flexing their hydrogen reserves. Others glow red and orange, filled with older stars nearing retirement. Some galaxies are greenish, a rare transitional color, where star formation is flickering out like the last embers of a dying campfire. You think of art. You think of Jackson Pollock, of Monet, of stained glass windows and kaleidoscopes. Then you laugh because this isn't art, it's just physics. At this scale, beauty is accidental, or maybe inevitable. You see galaxies distorted by gravitational lensing, curved into rings and arcs by the mass of other galaxies between you and them. Einstein predicted it. Telescopes confirmed it. Now you're watching light bend like liquid, revealing hidden objects behind the veil. And somewhere in the distance, a quasar blinks, one of the brightest objects in the universe, powered by a black hole at the center of a young galaxy devouring matter so fast it glows across billions of light years. It's hard to comprehend that all of this, every galaxy, every cluster, every quasar, is part of the observable universe, just the part we can see. Which begs the question, what's outside that? But you're not there yet. Right now, you're just floating through the cosmic downtown. The part where galaxies bump shoulders, where gravity paints with light and time, where the universe shows off. You don't try to count them. You already know how that ends. You just let them drift past. A river of worlds. A slow-motion parade of everything. And somewhere buried in one of those quiet spirals is your home galaxy. And somewhere inside that, a star. And orbiting that, a rock. And on that rock, someone staring up at the sky, whispering, "Are we really this small?" Yes, but you're also this vast. Because you're here. And you're seeing it. You drift through the galactic crowd, the glow of 1,000 galaxies receding into the velvet behind you. It's tempting to linger, to spiral through just one more cluster, to trace the slow arcs of merging spirals like they're constellations in motion. But the current of curiosity pulls you forward, and suddenly, your vision zooms out again. What you see now isn't just galaxies, it's structure. The galaxies you've passed, those billions of luminous islands, they aren't scattered randomly. They're arranged in filaments, knots, and walls, all woven into a sprawling, three-dimensional cosmic web. This isn't just poetry, it's literal. The universe is a lattice, a sponge, a nervous system, a map drawn in gravity. And nestled inside one thread of this incomprehensible web is Laniakea, your new neighborhood. A supercluster that contains 100,000 galaxies, including your own Milky Way. You're officially a resident of immense heaven. You coast across one of its gravitational strands, passing galaxies like snowflakes frozen mid-sneeze. Some still glow with star-forming frenzy. Others are ancient, red, and quiet, their internal fires dimming into cosmic retirement. Laniakea itself spans over 500 million light years. That's 5 followed by 8 zeros, in case your brain is trying to shrug it off. It includes known structures like the Virgo cluster, the Great Attractor, and a few other honking great knots of galaxies that warp space like bowling balls on a trampoline. Historians still argue whether superclusters like this are stable structures or just temporary clumps, bound by chance, not destiny. After all, the universe is expanding. Even gravity, for all its persistence, is losing the long war against cosmic inflation. But we do know this: our motion isn't random. You're not just sitting still in space. Your galaxy is moving. Your whole local group is drifting toward a mysterious region known as the Great Attractor. Sounds like a Marvel villain, doesn't it? It's a region of space so massive, so gravitationally intense, that it pulls entire clusters toward it. We can't even see it properly because it's hidden behind the plane of the Milky Way. Some call it a hidden mass. Others suggest it's just part of a larger structure, the Shapley supercluster, even farther out. Fringe theorists, because of course they exist, have posited that the Great Attractor could be a sign of something more exotic, a rupture in the fabric of spacetime, a leak from a parallel universe, a bruise left by a previous cosmos. Most scientists politely decline to follow those trails, but the point remains: something is tugging us, has been for eons. You can feel it now, that gentle pull. Like being on an escalator you didn't realize was moving until you looked up and noticed the ceiling getting closer. Everything in your corner of the universe is falling, slowly, invisibly, toward this unseen force. You spin slowly in space and take in the broader context. You see walls of galaxies, immense structures stretching across space like tectonic plates made of stars. The Sloan Great Wall, the Hercules, Corona Borealis Great Wall, each hundreds of millions of light years long. They bend your mind. They challenge what the word structure even means. One wall, the Hercules, Corona Borealis, is so vast that it may not fit within our models of the universe at all. Historians still debate whether it's a fluke, an artifact of our limited vision, or an actual violation of the cosmological principle. The idea that, on a large enough scale, the universe should be roughly the same everywhere. Spoiler, the universe disagrees. And yet, even in this overwhelming scale, you see voids, great empty bubbles of near-nothingness between filaments. These are the cosmic deserts, regions where galaxies are sparse, like skipped stitches in the quilt of creation. One of them, the Boötes Void, is nearly 330 million light-years across. That's not just empty, that's spooky empty. You could fit thousands of galaxies inside it and still have room to host an awkward intergalactic conference with terrible snacks. You glide along the edge of one now. There's a silence to it, not just in sound but in presence, like walking into a room where everyone has just left. It makes the packed clusters feel louder by comparison. Here, in the gentle cradle of Laniakea, you feel the rhythm of the universe shift again. No longer the slow churn of stars or the weighty pull of galaxies. It's something broader now. A pattern you can't see all at once, but you sense it. Like ripples in a pond you didn't know you were standing in. Every part of the cosmos has been arranged, not deliberately, but with consistency. The cosmic web didn't form randomly. It's shaped by gravity, yes, but also by the remnants of the Big Bang, by dark matter scaffolding, by ancient shockwaves from early inflation. Fringe hypothesis time. Some scientists have wondered whether the structure of the universe might reflect underlying mathematical truths, deep symmetries in spacetime itself, as if the universe were solving an equation too large for any single brain to read. You float back into the flow of galaxies now. Laniakea surrounds you like a fog of light, each pinpoint a sun factory, each cluster a drama unfolding over billions of years. You notice something odd, movement on a scale you can't quite accept. Every galaxy is moving, but not randomly. The whole supercluster has a flow to it, a drift, like leaves in a current. Everything in your galactic neighborhood is being drawn toward some center, some gravity well you can't see. Not the center of the universe, that doesn't exist, but a center of mass, a temporary low point in this cosmic landscape, a swirl of space folding in on itself. And just like that, you get a strange, quiet thought. Maybe the universe isn't just expanding. Maybe it's stretching and folding like dough. Maybe space doesn't grow forever in every direction. Maybe it twists, loops, breathes. The kind of idea that makes physicists stare at chalkboards until their coffee gets cold. You pull back a bit more, your dream speed adjusting. And there it is again, your home, not Earth, not the sun, but the Milky Way nestled among its peers in this cluster of clusters, still part of Laniakea, still drifting, still spinning, still holding on. From here it looks small again, like it did from outside, because everything gets smaller the farther away you drift. Even meaning, even memory, even you. But it's okay, because zooming out isn't about losing things. It's about perspective. You're not shrinking. You're expanding. Now the light starts to thin again. You've drifted out from Laniakea's bright maze of galactic clusters and walls, back into a gentler stretch of space. There are still galaxies all around you, like scattered lanterns in a fog, but they're more spread out now. Quieter, a little like rural galaxies living at the edge of the cosmic county line. This is the part where things start to get slippery. Because you're about to reckon with the distinction that has haunted cosmologists since the first telescope tilted toward the stars. What we can see versus what actually exists. You're entering the idea of the observable universe. Let's start simple. The observable universe is the part of the universe from which light has had time to reach us since the beginning of time, roughly 13.8 billion years ago. But here's the head twister. Because space itself has been expanding the whole time, that light didn't travel in a straight line. The thing that sent it, it's no longer where it used to be. It's now much farther away. So even though the universe is only 13.8 billion years old, the diameter of the observable universe is about 93 billion light years. Yes, that's what happens when space doesn't sit still. You get math that makes you blink very slowly and reconsider eating solid foods. It's like if you sent a balloon across a room, but the room kept stretching while the balloon floated. When the balloon finally reaches you, you turn around and the far wall is now 3 neighborhoods away. Surprise. Historians still argue over whether the term observable universe gives people the wrong idea, like there's a big cosmic wall or something. There is. There's no hard edge, no warning signs, no galactic end-of-line barriers, just a fade, a horizon, the limits of what light can reach us before it becomes forever invisible. This is called the cosmic light horizon. Everything inside this horizon, we can, in theory, observe it. Everything beyond it, we probably can't. Not now, not ever. Not because it doesn't exist, just because the light hasn't made it here yet, or never will. Some regions are moving away from us faster than the speed of light, not because they're sprinting through space, but because space itself is stretching between us and them. And yes, that's allowed. Space isn't bound by the speed limit. Light travels at 299,792 kilometers per second through space. But when space expands, that's a whole different loophole. So picture it. You're surrounded by a perfect cosmic bubble. Everything inside that bubble is the observable universe. You can, in theory, receive photons from those regions. You might detect ancient light, distant galaxies, even signals from the early universe itself. But just outside that horizon, nothing. Not because it's empty, because it's invisible. You float at the edge of this idea, not a physical place, but a conceptual boundary, a soft ceiling to your cosmic awareness. And now comes the uncomfortable thought. If the observable universe is only what we can see, what about the rest? How big is the actual universe? The short answer, no one knows. The longer answer, we have guesses, all terrifying. Some estimates suggest the universe might be hundreds or even trillions of times larger than what we can observe. And some theories go further, suggesting the universe may be infinite. But we'll get to that mess later. For now, consider this. If the observable universe is 93 billion light-years wide, then every direction you look is a time machine. When you gaze at something 10 billion light-years away, you're seeing it as it was 10 billion years ago. The further out you look, the further back in time you're peeking. Eventually, you hit a limit, not just spatial but temporal. You're seeing the cosmic microwave background, the faint afterglow of the Big Bang, stretched into microwave radiation by the expanding universe. It's the oldest light we can observe. About 380,000 years after the Big Bang, the universe cooled enough for photons to travel freely, and they've been drifting ever since. You hover near this wall of primordial light. It surrounds you like a sphere, the first photograph of the universe in baby pictures, dim, ghostly, and everywhere. You're not seeing stars here. You're seeing the fog lifting from the first fires. Fringe theorists have argued, half seriously, half wistfully, that maybe the observable universe is just a simulation boundary, like the edge of a loaded map in a video game. Maybe the reason we can't see beyond it is because there is nothing beyond it. The level hasn't loaded yet. The standard cosmological model doesn't endorse that, but it does suggest this. We'll never know what lies beyond the observable edge. Not fully, not directly. The laws of physics have drawn a curtain across the rest. But they didn't do it out of cruelty. They did it out of math. Back in the 20th century, a Belgian priest named Georges Lemaitre proposed the universe was expanding. This idea was confirmed by Edwin Hubble, who noticed galaxies were all racing away from us, with speed proportional to their distance. That discovery laid the foundation for the Big Bang model. But even now, historians still debate the details. Was the Big Bang truly a bang, or just a rapid unfolding? Did it happen everywhere at once or at a single point? Was it a beginning or just a phase? Whatever it was, you're seeing its ghost. And that ghost is loud. Every time you switch on a radio, about 1% of the static comes from the cosmic microwave background. That's the universe whispering in your kitchen. You glance back into the bubble of the observable universe. From this vantage point, you see galaxies marching in rings of redshift, their light stretched by motion. You see the structure, the scale, the grand machinery of time and distance. And you realize something oddly comforting. This is your horizon, not the universe, because the horizon moves. If we wait long enough, billions of years, new light from distant galaxies will reach us. Our observable universe will slowly grow, like a balloon inflating from the inside. But at the same time, some galaxies will cross the threshold in the other direction, pulled away by cosmic expansion so fast that their light will never catch us again. It's a race, a gentle one, but still a race. Eventually, trillions of years from now, only the closest galaxies will remain visible. The rest, gone, forever, like ships that sailed over the horizon and never sent another signal. So this moment you're floating in, it's rare, it's temporary, it's privileged. You're living in a time when the universe is still visible, still legible, still showing its cards. And someday, future beings might look up and see only blackness. No cosmic web, no galaxies, just their own star system and an endless, featureless dark. They won't know what was out here. But you do, because you're here. And you've seen the edge. You've floated all the way to the edge of the observable universe, brushing your fingertips against the limits of light and time. And now you're drifting farther still. Out here, the horizon is no longer a boundary, it's a memory. Behind you, the 93 billion light-year wide bubble of visible reality shrinks into a glowing sphere of potential. All the stars, galaxies, and cosmic web filaments now look like specks scattered inside a snow globe you can't quite shake. But there's more. There's always more. Because the real kicker isn't just how big the universe is, it's how fast it's getting bigger. See, you probably thought the universe expanded fast at the beginning and then slowed down, like a firework fizzling after it blooms. Makes sense, right? Big explosion, then gravity pulls things back a little. Well, no. The universe is pulling a fast one, literally. It's not just expanding. It's expanding faster and faster. This is what scientists call cosmic acceleration, and it's driven by something we barely understand: dark energy. It sounds cool, mysterious, like the name of a forgotten Star Wars movie. But in reality, it's just our label for whatever is causing the expansion of space to speed up over time. And it's winning. The discovery of this acceleration came in the late 1990s, when astronomers were studying Type Ia supernovae, standard candles that let us measure cosmic distances. They expected to find that the universe's expansion was slowing, but the data didn't match. Instead, it showed the opposite. Galaxies far away were moving away faster than expected, as if some invisible force was pushing the universe apart, harder and harder over time. Historians still argue whether Einstein's cosmological constant, a term he once called his greatest blunder, was actually a stroke of genius. He added it to his equations to prevent a dynamic universe, then removed it when it turned out space was expanding. Now, we've added it back in, with a different name and a healthy dose of confusion. Some cosmologists think dark energy is a constant property of space itself, like space just has an innate drive to stretch. Others think it might be a dynamic field, something changing over time, maybe destined to switch off or go wild. And here's the kicker. Dark energy makes up about 68% of the total energy content of the universe. Let that sink in. Everything we can see, stars, planets, gas, dust, your weird uncle's car collection, all that visible matter, less than 5% of the universe. The rest, dark matter and dark energy, stuff we can't see, touch, or fully explain. You float now in this accelerating universe, and you begin to notice something strange. Galaxies are receding faster than ever, not because they're moving through space, but because space itself is stretching between you and them. It's like ink dots on a balloon. Inflate the balloon and the dots move farther apart, not because they're walking, but because the surface between them grows. At a certain distance, this expansion becomes faster than the speed of light. That's not illegal, by the way. Einstein's speed limit only applies to things moving through space, not space itself. So what happens when a galaxy is far enough away that it's receding faster than light? You can't see it, not now, not ever. It slips beyond your cosmic event horizon, a different limit from the light horizon you passed earlier. This one's not about how old the universe is. It's about how fast it's expanding. Everything beyond this horizon is receding faster than light. That means any light emitted by those galaxies, no matter how long we wait, will never reach us. They are permanently out of reach. Gone. Some galaxies are slipping beyond that line right now, one by one, quietly. No flare, no goodbye, just a soft drift into oblivion. This is the ultimate loneliness of cosmic acceleration, the idea that the universe is slowly cutting itself into isolated pockets. Over time, distant galaxies will become permanently invisible, not because they exploded or died, but because the universe grew too big too fast. Eventually, the only things visible will be the galaxies gravitationally bound to us, maybe our local group. The rest, gone, like stars fading into fog. You start to feel the consequences of this expansion, not in your body, but in your timeline. There is a future where the universe becomes dark, not because the lights go out, but because they move away too fast to ever see again. Even now, we estimate that about 94% of the galaxies that will ever be visible are already beyond our reach. They exist, but we'll never find them. Their light will never catch us. Their stories are already lost. It's like arriving late to a theater and realizing most of the movie has already been deleted. Fringe theory time. Some cosmologists speculate that this runaway expansion could end in a scenario called the Big Rip, where dark energy becomes so powerful that it tears apart galaxies, stars, planets, atoms, even spacetime itself. That's billions of years away if it happens at all. But still, fun bedtime thought. You drift farther into the thick of the expansion now, watching galaxies stretch like taffy across the void. You realize that you're moving with the universe, not through it. You're not leaving anything behind. The distances are leaving you. It's not like falling into a pit. It's more like everything else is floating away, gently, inevitably, silently. This is the great irony of cosmic acceleration. The universe is getting bigger, but your slice of it is getting smaller, a shrinking stage in an inflating theater. And yet somehow you don't feel trapped. Because knowledge is its own kind of freedom. You've seen the map, you've traced the edges, you've felt the stretch, the slip, the slow unraveling of the visible. You know the universe is big. You know it's growing. And now you know we'll never see all of it. But that doesn't make it less real. You float here at the edge of the known, not with sadness but with awe. Because the sky isn't a limit. It's an invitation. And it's not shrinking. Not really. It's expanding you. You're not drifting anymore, you're coasting. Not because you've stopped moving, but because there's nowhere left to rush. The galaxies that once crowded your view have thinned into distant sparkles. The cosmic web that once seemed tangled and busy now trails behind like a dream half remembered. You're floating now through a kind of idea more than a place. Past the observable, past the reachable, past even the familiar vocabulary of near and far. And space itself. It's no longer stretching at a gentle pace. It's racing, roaring, expanding so quickly that light can't keep up. Yes, we're going there. You've entered the realm where expansion outpaces light. Where even photons, those massless speed champions, can't close the gap. Because now, the fabric of space is unraveling so fast that distance outruns the fastest thing in the universe. It sounds wrong, impossible. And yet here you are. Let's pull the thread gently. This isn't light breaking a law, it's space changing the race. Light moves at a constant speed, but when the space between 2 points is inflating faster than that speed, light loses ground. Imagine trying to swim upstream in a river that's flowing faster than you can paddle. No matter how hard you swim, you're pulled backward. That's the fate of photons from certain parts of the universe now, forever falling behind, their signals stretched and swallowed by accelerating space. And with every passing second, more of the universe slips into that unreachable zone. You float in it now, this endless, fast-forwarding cosmos. It doesn't look different, no flashing signs or speedometers, but you feel it. The way distant galaxies blur, fade, dissolve into redshifted silence. This redshift, the stretching of light to longer wavelengths, isn't just cosmetic, it's proof. Galaxies moving away from us appear redder because their light is stretched by the expansion of space itself. It's how we know they're running from us, or rather, being pulled away. At extreme distances, redshift becomes so severe that visible light turns to infrared, then to microwaves, then to radio waves. Eventually, it fades into wavelengths too long to detect at all. Light that once blazed with starbirth and galaxies now becomes background noise. And then nothing. You're drifting through that nothing now. But don't confuse silence for stillness. This region isn't empty, it's just disconnected. The cosmic event horizon, the ultimate boundary of communication, is right here with you. You're not at the edge of the universe. You're at the edge of influence. Beyond this point, no information can ever reach you. Not because it's blocked, but because it's simply outrun. The light from those regions is still traveling, but the space between you and it grows faster than the light can close it. Historians still argue whether this horizon is permanent, or whether some future twist in cosmic physics might let us cheat it. Some theorists propose modifications to gravity, or speculate that quantum effects might one day punch a hole in the firewall. But for now, this is the hard ceiling of knowability. Beyond this point lies the unseeable. You drift onward, quiet, watchful. There's no visual boundary, no shimmering line in the dark. Just a slow thinning, a dimming, a deepening sense that you are no longer part of what you see. You're observing things that can never observe you back. The stars become redder, then infrared, then gone, and you keep floating. At this scale, even time begins to feel different. The usual seconds and minutes have given way to a slow, syrupy awareness, like you've stepped into a thicker kind of existence. You glance behind you, not at Earth, not even at the galaxies, but at the bubble of the observable universe you left behind. It's still there, still bright, but shrinking in your perception, like a campfire on a vast plain. It looks small now and quiet, and still you don't feel lost. Because this isn't exile. This is perspective. You remember Voyager 1, that brave little dot, still transmitting in the dark. And now you are Voyager 2, just on a different scale. A traveler crossing conceptual frontiers, measuring not kilometers but comprehension itself. Fringe idea time. Some cosmologists speculate that beyond this accelerated space, there may be regions of the universe completely disconnected from ours. Places where physics is different, where matter clumps differently, where galaxies never formed or formed too fast or look nothing like spirals and swirls. They might as well be different universes. And maybe they are. Historians still debate whether the universe is infinite or simply very large. If it's infinite, then regions beyond our horizon aren't just distant, they're endless. Every possibility plays out, every configuration of atoms, every version of you. One of you stayed home. One of you became an astronaut. One of you just now spilled soup in their lap. But out here, those versions are invisible. Beyond the expansion, beyond the light, beyond the reach of any future. So you pause. Just breathe. Let your thoughts float like particles in intergalactic vacuum. The universe isn't a place, it's a process. It's doing something right now. Stretching, accelerating, pulling itself apart at speeds that twist your sense of direction. And yet, even in this high-speed unraveling, there's peace. Because you can feel it. You feel the expansion like a background hum, soft, cosmic tinnitus, woven into the vacuum itself. You feel it not as destruction, but as transformation. The universe isn't falling apart. It's becoming more. More space. More future. More places where something might happen. And maybe even here, beyond the light, something is happening. You can't know. But that's okay. Because now it's time to slow down. You exhale figuratively. There's no air out here, but your mind unwinds. The velocity eases. The stars thin to shadows. The glow behind you recedes like a fading song. The silence turns from overwhelming to soft. You've seen stars. You've passed through nebulae. You've skimmed galactic arms and coasted across voids larger than whole maps. And now you're floating in the deepest part of the dream. No more numbers, no more acceleration. Just breathless stillness. Let it settle in your bones. The realization that this was never about measuring size. It was about feeling it. The universe is big, yes, too big. But you're allowed to not understand it. You're allowed to rest in it. Let the boundaries fade. Let your thoughts slow to match the distant hum of space. There's nothing to chase here. just the dark and the light and the motion in between. Sleep now, little traveler. You've gone far enough for one night. You drift in stillness now. You've floated beyond the glare of familiar galaxies, past the glow of clusters, past the expanding horizon where even light has surrendered the chase. And here, in the darkest folds of the universe, you find something strange. Nothing, but not just any nothing. This is a different kind. Not the silence of a quiet room. Not the emptiness of a blank page. This is a nothing that doesn't even pretend to have an edge. You're trying to find the boundary of the universe. You're scanning for fences, walls, edges, drop-offs, curtains, something. But you won't find it. Because here's the twist most brains reject. The universe, as far as anyone can tell, has no edge. There's no outer wall, no dome. No, you are now leaving the known cosmos sign with a novelty font. You can go in any direction forever and never hit the end. How is that possible? Easy, just not intuitive. The current model of the universe describes it as finite in age, but possibly infinite in extent. You're living in a place that may loop around itself like a sphere, or extend endlessly like a flat plane with no borders. It may even be curved in higher dimensions, curled like the surface of a balloon, where you can keep walking and eventually end up where you started, without ever seeing an edge. Historians still argue over which model is correct. Some think the universe is flat, expanding infinitely in all directions. Others suspect it might be closed, with just enough mass energy to eventually loop around. Others say it's open, spreading out forever with no chance of return. The evidence? It's murky. We measure cosmic curvature using background radiation, galaxy distribution, and math Einstein would find exhausting. But our instruments can only peer so far. If the universe loops, it does so at a scale far beyond our current horizon. And here, where your mind starts doing cartwheels, you imagine standing at the edge of the universe and peeking out. But edge implies outside, and space doesn't have an outside. The universe isn't in something. It is the something. There's no external air, no shell, no cosmic floorboards. Space-time is the canvas, and you're not standing on it, you're woven into it. Imagine a game of Pac-Man. You exit off the right side of the screen and reappear on the left. That's a 2D analogy for a topologically closed universe. No edge, just endless looping. But here's the catch, it doesn't feel like looping. You never sense a curve. You never notice repetition. You keep moving forward in a straight line, and space just keeps going. You could fly forever and never reach a border. And even if the universe is infinite, it doesn't mean everything that can happen does. That's multiverse talk, we'll get there. But here, in our universe, infinity doesn't guarantee familiarity. You might drift for 1 trillion years and never see another Earth. Or another you. Because space is vast and randomness is cruel. Fringe theory time. Some models of a closed universe suggest that light from distant galaxies might wrap around space and reach us from the other side. Meaning we could, in theory, see multiple images of the same galaxy from different directions, like reflections in a cosmic funhouse mirror. So far, no evidence. But wouldn't that be a trip? You drift deeper, pondering the consequences. If there's no edge, then there's no center either. You might have imagined the Big Bang as a kind of explosion, with debris flying outward from a point. But it wasn't an explosion in space. It was an expansion of space. Everywhere was the center. Everywhere still is. You're not moving away from a cosmic origin point. Everything is moving away from everything else, uniformly. It's like baking raisin bread. The raisins are galaxies. As the dough rises, every raisin moves away from every other raisin, not because the raisins are crawling around, but because the dough between them expands. It's the same with galaxies and the space between them. This means you could travel in any direction forever and still not find a spot that's more central than any other. The universe has no privileged vantage point, no throne, no observation deck. Even Earth, charming as it is just one more raisin. And if that bruises your ego a little good, that's the point. You float now through what should be the edge, but it keeps not being the edge. Every direction you turn, there's more space, more silence, more potential. It's unsettling at first, then liberating. Because if there's no boundary, then there's no limit to wonder, no limit to discovery, no final page. You're in a story that doesn't end with a period. It ends with an ellipsis. And the nothingness you see isn't a void, it's unrealized space. The universe may be infinite in size, but not in experience. You'll never know all of it, but you don't have to. You just have to feel its shape. Right now, you're touching the idea of infinity, not by holding it, but by floating in it. You remember those ancient models of the universe, turtles all the way down, or giant crystalline spheres that encase the stars. Historians still argue how literally those cosmologies were believed. Were they metaphor, myth, or desperate attempts to give the infinite an edge? Because humans crave walls, boundaries, fences, but the universe offers you something better. It offers you a path with no wall to run into, a place where the journey is the destination. So you lean back, not to stop, but to savor the non-edge of everything, the loop that may never loop, the space that refuses to say you're done. And in that moment, you feel the most impossible truth of all. You are not floating toward the end of the universe. You are floating within it. Always, everywhere, forever. You drift untethered now, not just from planets and stars, but from the idea of edges altogether. No walls, no floor, no ceiling, only space, only motion without map. And then the thought hits you, what if this never ends? What if the universe just keeps going? Not metaphorically, not poetically, literally, infinite, not very big, not bigger than anything you can comprehend. Just endless. No boundaries, no looping, no curvature folding it back on itself, just a raw, infinite stretch of space and time. You're not the first to think this. In fact, cosmologists have been wrestling with it for decades, centuries, really. Back when people thought the stars were embedded in a crystal dome, infinity was a forbidden word. It broke things, like the mind. But now it's a serious candidate. The idea of a finite vs infinite universe isn't just a philosophical preference. It's a physical question, and one we're still nowhere near answering. Right now, most models suggest that the universe is spatially flat on the largest scales. That is, if you drew a triangle with 3 laser beams stretching across billions of light years, the angles would still add up to 180 degrees. And a flat universe strongly suggests something, infinity. Unless something's stopping it, some curvature too subtle to detect, or a hidden topological twist, we're likely floating in a universe that never ends. But hold on. Infinity is a tricky beast. It doesn't just mean a lot. It means everywhere goes on forever and no point is special. No center, no outer ring. Just galaxies as far as you can imagine, and then more. It means there are regions of space so far away, their light will never reach us. Not because it's too dim, but because space itself has stretched too far, too fast for that light to ever catch up. In an infinite universe, the observable cosmos is just a tiny patch, a drop, a smudge. You've spent your life in a galactic backyard, without realizing there's a whole continent beyond the fence. And that raises an even weirder possibility, a ridiculous, brain-bending, sleep-wrecking possibility. In an infinite universe, everything that can happen happens somewhere. Let that sit for a second. Every possible arrangement of particles, every combination of atoms must occur again. Not once, but infinitely. It's called the infinite monkey theorem. If you have infinite monkeys typing on infinite typewriters, one of them will eventually write the complete works of Shakespeare. Another will write it backwards. One will write only stage directions. And most will just mash the keyboard like they're writing angry tweets. Now imagine that applied to atoms. If the universe is infinite, then somewhere out there, there's a version of you, wearing a different shirt, slightly taller, slightly more confident in job interviews, and farther still, a version who never learned to read, a version who lives on a planet where gravity is half as strong, a version who never existed at all. It's not science fiction. It's just the logical consequence of infinite space and finite matter. Of course, that's assuming matter is evenly distributed, and that quantum randomness plays out in similar ways across cosmic distances. Historians still argue whether that's a valid extrapolation or a poetic oversimplification. But the point remains, infinity changes the rules. In a finite universe, there are boundaries. In an infinite one, all bets are off. Fringe theories stretch this idea to its limits. Some physicists propose that if the universe is infinite, every possible history unfolds in it. Not just every configuration of matter, every timeline. A version of you who took a different path, who asked a different question, who never floated into this endless dream of space. And the you that is here, you're just one permutation in an uncountable sea. It sounds wild, but it's not superstition. It's math. Infinity doesn't care about your comfort. It doesn't apologize for repetition. It just is. So now you're floating not just in space, but in possibility. You look around and see nothing. But in your mind, you see everything. You see galaxies repeating in slightly altered form. You see your own story playing out with slightly different inflections. You see versions of this very moment, again and again, stretched across a cosmic grid you'll never trace. And somehow you don't feel small. You feel woven, like you're part of something fractal, like your thoughts, your consciousness, are just one ripple in a sea of endless becoming. And even if that's overwhelming, it's also beautiful. Because in a truly infinite universe, you're not just here by chance. You're here inevitably. And that means your existence isn't just possible. It's required. The atoms that make you up, they had to arrange like this somewhere. And here you are. Not because the universe made you special, but because it made everything. And you're part of that. Historians still debate whether infinity is physically real or just mathematically useful. Some argue that actual infinities cause more problems than they solve. That no measurement can confirm something endless. That perhaps infinity is a mirage, a placeholder for ignorance. But others say, look at the math. Look at the patterns. The universe doesn't blink at big numbers. It breeds them. So maybe the real question isn't, is the universe infinite? Maybe it's, what kind of infinite are we living in? Is it directional, dimensional, layered? Or is it something stranger, something you can't name yet? You float quietly in that thought. There's no ending coming. No curtain to fall. No, here's the edge to cross. The story keeps going. So you stay with it, drifting in an existence that doesn't close. that doesn't collapse, that doesn't repeat, but contains repetition. And all the while, you're still you. You're still this one. In this branch. In this float through the dark. Let that be enough. You're already adrift in infinity, cosmic, boundless, quiet, and yet somehow, the universe manages to peel back another layer. You thought the absence of an edge was wild. You thought drifting through the concept of endless space was enough brain stretch for one night. But now you float into the question that shouldn't even be possible. What if there's more than one universe? Yes, it's time. Welcome to the multiverse. And no, this isn't Marvel. No capes. No alternate versions of yourself buying coffee in slow motion. This is the real deal, or at least the real theory. Because as much as physicists hate sounding like sci-fi authors, many now believe the idea of multiple universes might not be as absurd as it once seemed. You're not just in a universe. You might be in one of many. A bubble, a blip, a single room in a house with infinite doors. And suddenly, the size of our universe, 93 billion light-years wide and possibly infinite, feels quaint. So what are we talking about here? There are several versions of the multiverse idea. Let's take a gentle drift through the weirdest real estate tour in existence. 1. The cosmological multiverse. This one comes straight from inflation theory. After the Big Bang, the universe underwent a period of inflation, a brief but astonishingly fast expansion that smoothed out space and launched everything into motion. But what if inflation never completely stopped? Some models suggest that pockets of space stopped inflating at different times, creating isolated bubbles of normal space, each one its own universe, with its own laws of physics. This process could be ongoing. New universes budding off from the inflating fabric of reality, like soap bubbles from a wand. Or is this just one? You float outside our cosmic bubble now, and see others. So many others. Some overlap, some drift, some collide. What's in them? We don't know. Maybe nothing. Maybe something so alien you wouldn't recognize it. Historians still argue whether this idea is testable, because if these universes are truly separate, sealed off by expanding space faster than light, then they are forever beyond our reach, beyond our math, beyond our data. But just because we can't measure them doesn't mean they're not there. 2. The quantum multiverse. Let's go small, really small. Down to particles, probabilities, and the thing that makes Schrödinger's cat such an awkward dinner party story. Quantum mechanics tells us that particles don't have definite positions or velocities until they're measured. Instead, they exist in superpositions, multiple states at once. And every time a measurement happens, reality chooses an outcome. But what if it does? According to the many worlds interpretation, all outcomes happen. Every quantum possibility splits reality into a new branch. You go left, one universe. You go right, another. You sneeze during a job interview. That's a whole new timeline right there. You are a branching tree of decisions, observations, and quantum events, endlessly flowering into variant realities. You float now between these branches. You feel the ghost of your other selves, not metaphorically but physically. Each one real, each one with their own version of you lying on the grass at night, wondering about the stars. It's not just poetic. Some physicists argue it's the most mathematically consistent explanation for quantum mechanics. But is it science? Historians still debate that. Because if you can't interact with the other branches, is it real physics or just philosophical framing? Still you float, and you can't help but feel it. The weight of possibility, not just across space, but across version. 3. The simulated multiverse. ready to lose your grip a little. Some physicists and philosophers suggest that we might be in a simulation. Not metaphorically, literally. The idea goes like this. If it's possible to simulate consciousness, and we ever develop that technology, then advanced civilizations could run billions of simulated universes for science, entertainment, or, really intense retro gaming. Statistically speaking, simulated universes could outnumber real ones by a terrifying margin, which means the odds that we are real might be very, very low. You drift through code now. You see the lattice, the math, the repeating decimals. You wonder if the speed of light, Planck's constant, and quantum uncertainty aren't laws of physics, but rendering limits. It sounds absurd. And yet, the more we learn about the universe, the more it looks suspiciously computable. Historians still argue whether this theory is testable. Could we find a pixel-sized to space, a glitch in the matrix? Or is the very act of asking just part of the code? You laugh softly, because what else can you do? 4. The brain multiverse. String theory time, don't panic. Some variations of string theory propose that our universe exists on a three-dimensional membrane, a brain floating in a higher dimensional space. Other brains float too, parallel universes, stacked or swaying nearby. Sometimes they might even collide. Some cosmologists think such a collision might have caused the Big Bang. You drift sideways now, past invisible dimensions. Space folds and creases. You sense other brains, other universes, so close and yet unreachable. Each one vibrating with different rules, different particles, different beginnings. It's less like parallel lines, more like sheets on a cosmic laundry line, flapping in a multi-dimensional wind. And then you stop floating. You just hover. Because suddenly, it's not about the physics anymore. It's about you. You, the thinker, the observer, the speck of dust that somehow got curious. In a multiverse, your place in things doesn't shrink. It expands. Infinitely. There isn't just a universe big enough to hold you. There's a reality with room for every possible version of your existence. Even this one. Even here in the dark, listening to a voice tell you that it's okay not to understand all of this. Because maybe comprehension isn't a destination. Maybe it's the act of wondering. And floating through the multiverse, idea or not, is just one more way you reach out. Not to grab answers, but to feel how wide the unknown really is. So you breathe again. A deep fictional dream breath. And you let yourself feel it. The layers, the versions, the everything. You don't have to decide if it's real. You just have to let it be possible. And in that possibility, you've already expanded. You're weightless now in every sense. No gravity, no anchor, not even to reality itself. You've floated through the known universe, peeked over the edges of what's visible, tiptoed past the horizon of light, and grazed the outer rim of theoretical existence. Multiverses, membranes, infinities, all behind you like glimmering thoughts on a sleepless night. But now you turn inward. Because as it turns out, the universe isn't the only thing that's unfathomably vast. You are too. Let's shrink the camera. Zoom in. Closer. Past your skin. Past the cells, past the tangled biology of organs and bone and memory. You're not a solid object, not even close. You are in fact mostly empty space. That's not an insult, that's atomic truth. Each atom in your body is 99.99999999999% empty. That decimal is not exaggeration, it's your physical truth. The nucleus of an atom is so small compared to the whole atom that if it were the size of a peanut, the entire atom would be the size of a baseball stadium. Electrons zip around it in clouds, regions of possibility rather than fixed orbits, more ghost than gear. You're not made of matter. You're made of probability. Historians still argue whether electrons orbit at all. The classical image of tiny balls circling a nucleus like miniature planets, cute but outdated. Modern physics treats them as clouds of likelihood. They exist here-ish, sort of, maybe. And these clouds define your shape, your presence, your mass. They interact with other clouds to make molecules, which make cells, which make you, a walking bag of quantum fuzz. And that's just the start. Zoom deeper and even your protons and neutrons, the stuff in your nuclei, are made of quarks held together by gluons. The strong force, one of the four fundamental forces of nature, is what keeps those quarks glued in place. It's unimaginably powerful, yet confined to unimaginably small spaces. So small that no one ever seen a quark on its own. They're always locked in teams, always dancing in threes or twos, like it's some kind of subatomic buddy system. And beneath even that, we're not sure. String theory suggests everything is made of tiny vibrating strings, loops of energy oscillating in multiple dimensions. Others propose spacetime itself is quantized, made of tiny grains at the Planck scale. Fringe theory time. Some physicists believe that everything, particles, forces, even mass, emerges from information. That reality itself is woven from binary codes. Not matter, not energy, just bits, zeros and ones, on and off. You float among your atoms now, each one mostly empty, a blur of motion, a field of probabilities. And you start to realize you are not solid. You are not continuous. You are temporary structure, a storm of particles shaped by patterns that will eventually dissolve. And still somehow you think. You dream. You drift through the cosmos, asking impossible questions with a brain made of vibrating ghosts. Here's the irony. You've spent all this time trying to comprehend the size of the universe. And now in the smallest parts of you, you find the same riddle. There is no solid ground, no firm edge, only uncertainty, scale and patterns nested within patterns. Inward and outward, the universe repeats itself, not in shape but in mystery. Because whether you're looking at galaxies or quarks, stars or electrons, you run into the same truth. The closer you look, the less certain things become. You want to hold a single particle in your hand. You can't. You want to pinpoint an electron's position and velocity. You really can't. This isn't a flaw in our instruments. It's baked into reality. Welcome to the Heisenberg uncertainty principle, the idea that certain properties of particles can't be known precisely at the same time. The universe doesn't give you a readout, it gives you a fog. And you're made of that fog. You, the one lying awake thinking about the stars, are a miracle of uncertain stuff, momentarily coalesced into certainty. That breath you just took, it used atoms made in a star. Those same atoms were once scattered across a collapsing cloud of dust, shaped by the same physics that governs galaxies. Historians still debate whether ancient philosophers, like Democritus or Indian sages of the Vedic age, truly grasped the scale of atomic theory, or were just gesturing toward intuition. Either way, they weren't far off. The body is not a vessel. It's a field of fields. And consciousness. We don't know. Fringe idea. Some researchers think consciousness arises not from complexity alone, but from quantum effects in the brain, tiny entangled states flickering across synapses. It's controversial, maybe nonsense, but maybe not. You float now in your own molecules, and you feel the same, all you felt floating between galaxies. Because it's the same motion. Scale changes, wonder doesn't. Every cell in your body contains mitochondria, tiny energy factories that were once independent organisms. Billions of years ago, they struck a deal with primitive cells. Now they power you. Your body is a symbiotic treaty, signed before Earth had continents. Your DNA. It's 4 simple letters arranged in a code. And in every cell of your body, trillions of them. That code is folded, copied, repaired, rewritten. You're made of text, of language, of instruction. And the atoms in that DNA, they're borrowed from Earth, from stars, from time. Eventually, they'll return. Your body isn't yours. It's a loan from the cosmos, shaped into temporary meaning. And all of this, the quarks, the fields, the structure, the code, comes together to make you. You who wonders. You who listens to the dark. You who lies on the grass and tries to comprehend everything. Even now, as you drift in the imagined quiet of the deep, you carry the cosmos inside you. Not metaphorically, literally. Because the universe is not just out there. It's U-shaped too. You hover now, suspended in yourself and beyond yourself, that paradox still echoing in your chest. You are made of mostly nothing, and yet, somehow, you are here. Conscious, curious, full of questions about a universe so large and layered that even the numbers meant to measure it collapse under their own weight. So let's turn to something we haven't touched yet. Something almost as strange as the cosmos itself. How do we even measure it all? Because asking how big is the universe is like asking how long is forever, or how deep is meaning. And yet cosmologists have tried, are still trying to measure the immeasurable. And to do it, they've had to invent some truly weird ways to measure big things. So you let yourself drift again, not through space this time, but through the bizarre language of measurement. First up, the light year. You already know it. It's the distance light travels in a year, about 9.46 trillion kilometers. That's our standard ruler out here. But even that's too clunky when you're talking about the really big stuff. So instead, we use parsecs. Yes, the word Han Solo misused in Star Wars. And no, it wasn't just a throwaway line. He did mess it up and fans noticed. 1 parsec is about 3.26 light years. It stands for parallax arcsecond, and it's based on geometry, how a star's position appears to shift as Earth orbits the sun. Astronomers use this shift to estimate distance. It's clever, tricky, and incredibly effective, at least for nearby stars. But even parsecs get left in the dust when we start talking about megaparsecs. That's millions of parsecs, used to describe the spacing between galaxies and clusters. You've gone from tape measure to telescope to cosmic Google Maps. And it still isn't enough. Because measuring the universe means looking not just across space, but backward in time. Every galaxy you observe is a snapshot from the past. So cosmologists often measure things by how redshifted their light is. Here, how it works. When galaxies move away from us, thanks to that delightful expanding universe, their light is stretched. Just like a siren lowers in pitch as it passes you, light shifts toward the red end of the spectrum when its source is receding. This stretching is called redshift, and it's not just a color change. It's a measurement of distance, velocity, and time, all rolled into one number. A redshift of 1, that galaxy's light has doubled in wavelength. A redshift of 10, it's really far. A redshift of 1100. Now you're seeing the cosmic microwave background, the earliest light in the universe. You float in that light now, just like before. The universe's baby picture, a warm afterglow from a time when atoms first formed. That radiation has been traveling for 13.8 billion years, stretched and faded until it now registers as microwaves, a faint hiss in every direction. In fact, if you had an old analog TV, about 1% of the static between channels came from that signal. You were literally picking up the Big Bang in your living room. You smile at the thought, because somehow measuring the universe is a mix of science, magic, and microwave leftovers. But that's just the beginning. Another trick cosmologists use is something called a standard candle. No, not the scented kind. These are astronomical objects whose brightness we know exactly, like Type Ia supernovae. These exploding stars always blow with the same intrinsic brightness. So by comparing how bright they should be to how bright they appear from Earth, we can calculate their distance. It's like recognizing a 100-watt bulb from across a field. If it looks dimmer than expected, you know it's farther away. This method, called the cosmic distance ladder, lets us map galaxies like waypoints, leapfrogging our way deeper into space. And then there are baryon acoustic oscillations. Yeah, that one sounds like a prog rock album title, but it's real and incredibly useful. These are subtle ripples in the distribution of galaxies, left over from sound waves that traveled through the early universe's plasma. They've left behind a sort of cosmic fingerprint, a repeating scale that helps measure distances on truly vast scales. Like a ruler embedded in the very fabric of the cosmos. You float past one now, not a ripple you can see with your eyes, but a statistical rhythm in the arrangement of galaxies. They clump in ways that aren't random. They echo patterns set down when the universe was just 380,000 years old. Even now, they whisper the past across billions of light years. Historians still argue how many rungs we can add to the cosmic distance ladder, whether the methods break down at extreme redshifts or if we're underestimating dark energy's role. But the ladder holds, and we keep climbing. You glance inward again, back toward Earth. Remember how ancient people measured the heavens with sticks, shadows, and clever triangles. Eratosthenes, around 240 BCE, estimated Earth's circumference using sunlight and a well. It's one of history's greatest feats of scientific intuition. We've gone from wells to telescopes, from string to satellites, from shadows to redshifts. But it's still the same instinct. How far is that? And every time we invent a new answer, the universe asks a bigger question. Sometimes we measure time itself. There's a thing called look-back time, how far back in time we're seeing when we observe distant galaxies. A galaxy 5 billion light years away. We're seeing it as it was 5 billion years ago. Not because it's aged since, but because its light only just arrived. You're never looking at the universe as it is, only as it was. A rolling cascade of memory and delay. The further you look, the older the story. Until you hit the fog before atoms formed, and everything becomes opaque. And yet here you are. A mind built from particles, trying to measure everything that gave it birth. There's something poetically absurd about it. Like a wave trying to measure the ocean. Like a candle trying to estimate the size of the night. But still you try. Because measurement isn't about conquering scale. It's about carving understanding out of chaos. Every light year, every parsec, every redshift number you've encountered. They're reminders that you live in a measurable mystery. That even infinity can be mapped. Not with answers, but with questions. So now you stop floating, just for a moment. You let the cosmic rulers fade. You forget the units, the digits, the expanding balloon analogies. And you ask a softer question. Does it matter how far it goes? Because now, you're not measuring the universe to control it. You're measuring it to honor it. And in that reverent pause, you realize something beautiful. You are not lost in this vastness. You are participating in it. Every time you measure, you're reaching out. And every time, the universe stretches beyond the ruler. It's reaching back. You floated through galaxies and clusters, across voids and horizons, and deep into the architecture of your own atoms. You've seen the universe unfold outward and inward, immeasurable, intricate, and in every direction, quietly expanding beyond your ability to fully understand. So now comes the big, slippery question, the one that turns everything sideways. What if it isn't even real? Not real like imaginary, not real like a dream, but not fundamentally real in the way you assume. What if the universe, this enormous, ancient, jaw-dropping place you've been floating through, is not the base layer of reality at all? Welcome to the simulated universe hypothesis. Go ahead, roll your eyes if you need to. Even seasoned physicists do that sometimes. But then they keep thinking about it. Because the theory isn't just sci-fi fluff, it's surprisingly hard to dismiss. You hover now in a strange space, not physical but philosophical. Not among galaxies but code. Possibility, logic, computation. Let's lay the groundwork gently. In 2003, philosopher Nick Bostrom published a now famous paper arguing that one of the following must be true. Civilizations go extinct before reaching the technological capability to simulate conscious beings. Civilizations reach that point, but choose not to simulate universes. Civilizations do create simulations, and there are so many of them. The number of simulated beings far outnumbers real ones. And if that third option is true, well, odds are you're not in the base reality. You're one of the simulations. Now that's not proof, but it's not easy to refute either. If it's possible to simulate reality indistinguishably from the original, then eventually someone will do it. Probably thousands of times. And so here we are. Fringe maybe, but it sticks. You float through that idea now. Not through galaxies, but through patterns. Not hydrogen and helium, but data. You start to see the universe differently. Particles become pixels. Forces become functions. Time itself becomes a clock cycle. Even our constants, like the speed of light or Planck's constant, begin to look suspiciously like system parameters. Fixed values, baselines, limits, not physical laws but software constraints. What if gravity is just an emergent behavior in a simulation? What if the cosmic speed limit is a rendering cap? What if quantum uncertainty isn't randomness, but compressed code being interpreted on the fly? You laugh softly because this should feel ridiculous. And yet it kind of doesn't. You remember all those glitches you've seen, not in the Matrix, in reality. Particles behaving differently when observed. Quantum entanglement, where two particles affect each other instantly across vast distances. The fact that time slows down when you move fast. These aren't bugs, they're just weird. But they're so weird, some physicists have started asking, what if they make more sense in a simulated framework? Imagine rendering a video game. The environment only loads when the player turns toward it. In quantum physics, particles behave similarly. They don't settle into a definite state until observed. Coincidence, maybe. But the comparison lingers. You float deeper into the idea. Imagine a civilization so advanced they could simulate entire universes. Not just the visuals, not just simplified versions, but full quantum systems, detailed to the point of consciousness. They might simulate their ancestors, their evolutionary history, even alternative versions of their own reality. And you might be one of those simulations. Not as a prank, not as punishment. Just curiosity. You're a thought experiment in motion. Historians still argue whether this is even a testable hypothesis. If it's a simulation, could you find the code? Look for rounding errors in physical constants. Detect pixelation in spacetime at the Planck scale. Some physicists have tried. So far, no smoking gun. But the thought remains. What's more unsettling is how little it would change. If the universe is simulated, then yes, it's artificial. But it's still functionally real. The stars still shine. The equations still work. You still feel, dream, love, grieve. Your experiences still matter. Because consciousness doesn't care about the substrate. Simulated or not, you are having a moment with the universe. Right now. Right here. And it's beautiful. If anything, the idea that this could be a simulation just adds another layer of awe. Because someone or something took the time to build this, to shape this, to generate galaxies, stars, atoms, you. Not just as data, but as story. And maybe, just maybe, the purpose of that simulation was to see if you'd ever stop to wonder. You drift now in that wonder. The simulation theory isn't the first to propose that reality isn't as it seems. Buddhist philosophy has long described the world as Maya, illusion. Plato spoke of prisoners in a cave, mistaking shadows for truth. Even modern physics tells us that what feels solid is mostly emptiness, and what feels still is in constant motion. Whether it's a computer or a cosmos, reality has always worn a mask. And here you are, trying to peek underneath it. Maybe that's what makes you real. Not your atoms, not your coordinates, not your certainty, but your curiosity. Simulated or not, you're alive in this moment, floating through a universe full of possibility, touching ideas like galaxies, and letting them orbit your mind. You don't need proof. You just need permission to imagine. So you turn your gaze back to the stars. Yes, maybe they're code. Yes, maybe they're holograms. Yes, maybe none of this is what it seems. But it doesn't have to be. Because even the idea that everything is simulated is just one more way the universe shows off its size. Not in distance, but in depth. You've made it to the outermost edge of thought, the place where science, philosophy, math, and wonder sit quietly together, shrugging and sipping tea. You've floated from the granular to the galactic, from atoms to everything, from certainty to absolute mystery. So now, in this last drift of the journey, one final question curls around you like fog. Can we really comprehend the size of the universe? You tilt in the dark, letting the question settle, not to solve it but to feel its shape. Let's be honest, you probably can't. Not completely, not all at once. Your brain evolved to chase gazelles, to find berries, to build chairs, not to grasp distances measured in billions of light years or to understand galaxies slipping beyond our cosmic event horizon. You think in footsteps, road trips, plane rides, maybe a cross-country map if you're really reaching. But space, time, infinity. They laugh at our intuitions. Even the smallest big numbers of the cosmos are enough to reduce the most ambitious mind to a quiet puddle of reverence. The observable universe, 93 billion light-years across, is just the beginning. It may be infinite. It may be part of a multiverse. It may be a simulation, a membrane, a flicker of something much older and stranger. You've been there, at least in imagination. And imagination counts. Because here's the twist. Comprehension isn't the goal. You're not here to solve the size of the universe like a math problem. You're not here to store its dimensions in your pocket like a souvenir. You're here to feel it. And you have. The dizziness when you pass through clusters of galaxies. The hush that fell over you in the Oort cloud. The chill of drifting past a rogue planet, all alone. The crackling quiet of the cosmic microwave background, like static from the beginning of everything. That's comprehension. Not in digits, but in emotion. Not in numbers, but in scale awareness. Because the truth is, understanding doesn't always arrive in full sentences. Sometimes it's a tingle, a blink, a whisper, A quiet little whoa in the back of your throat. You know the feeling. It's what you feel when you stand at the edge of the ocean at night, when the waves stretch into blackness, and you suddenly remember how very, very small you are. Or when you look up on a clear night, and for a split second, the stars don't just look far. They look endless. They look real in a way that turns your bones to glass. And for just that breath, you don't want to be anywhere else. Because suddenly, your size doesn't feel like a problem. It feels like belonging. Historians still argue whether humans ever truly understood the universe in any complete sense. Whether Newton or Einstein or Galileo saw the cosmos clearly, or just poked holes in the veil and caught glimpses of something much bigger. But maybe that's all we're supposed to do. Catch glimpses, and then gently pass them on. Like stories, like myths, like light that took billions of years to arrive. So can we comprehend the size of the universe? No. And yes, not all at once. Not in numbers, but in moments. Absolutely. In awe, in stillness, in dreams. We comprehend it there. Right now you feel it in your body, not as information but as sensation. The lightness in your chest, the looseness in your thoughts, that strange, satisfying ache in your head where words stop working and images start speaking. That's comprehension. That's your brain bending, just enough to fit a piece of the infinite inside it. Because here's the great irony. The universe is unimaginably huge, yes. But so are you. You with a brain that can simulate entire worlds in REM sleep. You with a heart that can ache for stars you've never seen. You who can lie on the grass, point at a tiny speck of light, and know it's not just a light, but a galaxy, a home, a time machine. You don't need to measure it. You just need to witness it. And in that witnessing, you become a part of it. Because the universe doesn't just contain you. It needs you. To see it. To ask about it. To love it. To get dizzy from it. To try clumsily, sleepily, bravely. To hold a piece of its size in your tiny, extraordinary mind. And maybe, just maybe, that's the best kind of comprehension there is. Word count, 1,100. Wind down, 300 words. So now you settle. You've journeyed through trillions of kilometers, danced on atoms, grazed the edges of existence, and asked the one question that has no final answer. Let it fade now. Let the vastness slip from your shoulders. Let your breath soften. Let your thoughts stretch out, not toward infinity this time, but toward peace. You don't have to understand everything. You never did. It's enough to know that you're part of something enormous, something ancient, something beautiful. The stars are still out there. The galaxies still spin. The photons still race across space to meet your waiting eyes. But for now, let them. You've done your part tonight. You asked. You drifted. You wondered. And now you rest. Float gently in the dark, in that warm, weightless space between dreaming and understanding. You are stardust. You are structure. You are story. The universe is not something you stare at from the outside. It is the place that made you, and the place you return to every time you close your eyes. So go ahead. Drift. Sleep. Let the galaxies turn without you for a while. They'll be there when you wake.